This video lesson is on the differences and similarities between linear and exponential functions. The first thing we're going to talk about is similarities and differences in the equations. So both linear and exponential functions are going to be terms of y. The difference is that linear functions are going to be in slope-intercept form, where y equals mx plus b, where m is the slope and b is the y-intercept. For an exponential function, they're written in the form y equals a times b to the x, where a is the y-intercept and b is the rate of growth or decay. And we'll get into that more a little bit later. But basically, when you're looking at an exponential function, you're looking for this x to be the exponent. Next, we're going to talk about tables. In a linear function, the rate of change is the same throughout. It's a common difference, which means that there's a common difference between each y. And in an exponential function, we can't add or subtract the same thing to get from one y to the next each time, but what we do is we multiply. So instead of being called a common difference, it's called a common ratio. And you find that by looking at what you would have to multiply to get from one to the next. Now with real-world situations, the easiest thing is to set up a table. So looking at this linear example, your savings account starts with 300. And every Friday you deposit $50 in your account. So the following Friday you would have $350, then $400, then $450, then $500, and so on. Well, what you have here is a common difference because you're adding $50 each time. So that's going to be a common difference, which means it's linear. If we look at the exponential example, your savings account starts with $10, and every month the amount in your account doubles. So the next month you would have 20 because 10 times 2 is 20. Well, then if 20 doubles, you have 40. If 40 doubles, you have 80. If 80 doubles, you have 160, and so on and so forth. But here, I'm not just adding 10 each time. What I'm doing is I'm multiplying by 2. So that's a common ratio. Because if it's doubling, I can't just add 10 to each one and have it be correct. Now looking at graphs, a linear function is going to graph a straight line. And an exponential function is going to graph a smooth, curved line. And it's either going to go curve up or it's going to curve down. Both would be considered exponential.